question is, what affects force and motion? For our experiment, we have a cup with the hole out of the bottom, marshmallows, and a balloon that we tied off the end and then cut off the large end.
For our first experiment, our testable question was, how does the force applied to the marshmallow shooter affect the marshmallow's distance? Our claim was, the more force applied to the balloon, the more distance the marshmallow will travel.
So our evidence was that we took the balloon and attached it to the cup, and when we applied a great amount of force, the marshmallow traveled farther than when we applied a small amount of force. So our conclusion is that the balloon that had the more force exerted on it caused the marshmallow to travel a greater distance.
For our experiment number 2, we used the cup with the balloon at the end, and we used a large marshmallow and a smaller marshmallow. And for our testable question, we asked, how does the size of the marshmallow affect its traveling speed? And for our claim, we said that the smaller marshmallow will have a longer traveling speed.
Right, so we started with the smaller marshmallow first, and we used the same amount of force for both marshmallows, and we pulled it back and let go, and it hit the table 2.22 seconds after we pulled the balloon. And for the larger marshmallow, we used the same amount of force, but this only lasted 1.40 seconds and traveled a shorter distance. In our conclusion, we found the smaller marshmallow had a slightly longer traveling speed than the larger marshmallow because it has a lighter mass, causing it to travel farther and increasing its traveling speed.
For experiment number 3, we're using the same materials that we used in experiment number 1, except we are using smaller marshmallows for better results. Our testable question is, how does the angle of the shooter affect the marshmallow's distance? And our claim is, the larger the angle of the cup from the table, the higher and further the marshmallow will travel.
For our evidence, we're putting the marshmallow inside the cup, and for the lower angle, we're going to launch the projectile, and then we're going to launch it at a higher angle, and we'll see which one goes farther. In conclusion, the cup with a larger angle created a higher arch, causing the marshmallow to travel farther before landing.
Low amount of force. Oh, it didn't even come out. Hold on. Low amount of force. Come on.
Go.
Here's the marshmallow being shot at a low angle. Where'd it go? Oh.
Bloopers.
Yeah. Okay, for real.
Okay, first we are starting with the smaller marshmallow, and we're gonna pull it back. Ooh. Just kidding.